Welcome to Month 5 of the Engineer Track. This session is titled DevOps and Deployment, from Local to Production. Over the next 4 hours, you will go from a locally running full-stack application to a live, cloud-hosted deployment with an automated CI/CD pipeline and working monitoring. The session focuses on Docker, GitHub Actions, cloud deployment on Azure, AWS, or GCP, and basic observability. The only prerequisite is completing Month 4 and being comfortable on the command line. Here is how the 4 hours are structured. In Hour 1, you will learn containerization fundamentals, Docker concepts, writing Dockerfiles with multi-stage builds, and orchestrating services with Docker Compose. Hours 2 and 3 are a hands-on build. You will containerize your full-stack app, set up a GitHub Actions pipeline that tests, builds, and deploys on every merge, deploy to a cloud platform, and configure monitoring. Hour 4 is for review and validation, testing the production deployment, reviewing the pipeline, and wrapping up with key learnings and the offline milestones for Month 6. By the end of this session, you will have 5 concrete capabilities. First, you will be able to containerize a full-stack application using Docker, writing production-grade Dockerfiles with multi-stage builds and minimal Alpine base images. Second, you will create multi-container setups with Docker Compose, defining services, networks, and volumes so the front-end, API, and database all run together locally with a single command. Third, you will set up a complete CI/CD pipeline with GitHub Actions, automated tests, Docker image builds, and cloud deployment triggered on every push to main. Fourth, you will deploy those containers to a cloud platform and configure HTTPS. And fifth, you will wire up structured logging, health check endpoints, and a monitoring dashboard. Let us start with the core Docker concept, the difference between an image and a container. An image is a blueprint, a read-only, layered snapshot of your application and all its dependencies. A container is a running instance of that image, a live process spun from the blueprint. One image can spawn many containers simultaneously. Each container is isolated from the others. Understanding layers and catching is what makes Docker fast in practice. Every instruction in a Dockerfile creates a new layer. If a layer has not changed, Docker reuses it from catch. This means you should always copy your dependency manifest files first, run the install, and then copy your source code. That way, source code changes do not invalidate the expensive dependency install layer. Putting frequently changing instructions at the bottom and stable instructions at the top is one of the most impactful habits you can build around Docker. The most important Dockerfile pattern for front-end apps is the multi-stage build. In Stage 1, you start from a full Node 18 Alpine image, install dependencies with npm-c, and run the production build. In Stage 2, you start fresh from a minimal Nginx Alpine image and copy only the compiled dist directory from Stage 1. The final image contains nothing from the build stage, no node's runtime, no source files, no dev dependencies. The result is an image of around 25 megabytes instead of several hundred. For the backend API, the pattern is similar but simpler. Start from Node 18 Alpine, copy the package files, run npm-c with the production flag, copy the source, and set the start command. The key discipline across both Dockerfiles is always using specific version tags, never the latest tag. So builds are reproducible months later when Node or Nginx releases a new version. Docker Compose is the tool that ties multiple containers together into a working application stack. Your Docker Compose YAML defines each service, front-end, back-end, and database as a named block. You specify the build context, the ports to expose, environment variables, and dependencies between services. The depends on directive ensures the backend starts before the frontend, and the database starts before the backend. All three services share a custom bridge network called App Network, which means they can reach each other by service name. The backend connects to the database using the hostname Postgres, not a raw IP address. Data is persisted across container restarts using a named volume mounted into the database container. Running Docker Compose up with the build flag brings the entire stack up locally, and Docker Compose down tiers it all down cleanly. CI/CD stands for continuous integration and continuous deployment. The idea is that every push to main should automatically run your tests, build your Docker image, push it to a registry, and deploy it to production, with no manual steps. GitHub Actions implements this through a workflow file that lives in your repository at GitHub Workflows Deploy YAML. The workflow is triggered by events, a push to main, a pull request, or a scheduled job. Each job runs on a fresh GitHub-hosted runner, a clean Ubuntu virtual machine that is provisioned, used, and discarded for each run. Jobs can depend on each other. The build job only runs if the test job passes, and the deploy job only runs if the build job succeeds. This gives you a gated pipeline where a failing test blocks a deployment every single time. A typical deploy YAML for this project has 3 jobs. The test job runs on every push, checks out the code, sets up node 18, installs dependencies with npm sci, runs the test suite with coverage, and runs the linter. The build job runs only if tests pass. It logs into the GitHub container registry using the repository token, builds the Docker image, tags it with the git commit eshe for traceability, and pushes it to the registry. The deploy job runs only if the build succeeds. It SSHs into the target server using a stored SSH key, a GitHub Actions secret, and runs a Docker pull, followed by a Docker Compose up to bring the new image live. The use of secrets is important here. Credentials, API keys, and SSH keys never appear in the workflow file itself. They are stored encrypted in the GitHub repository settings and injected as environment variables at runtime. For this session, you have 3 cloud platform choices, all at a medium difficulty level, and all offering free 3 tiers suitable for this challenge. Azure Container Apps is a managed container service tightly integrated with Azure Active Directory and Key Vault. It supports auto-scaling and is a natural choice if your organization is already on Azure. AWS ECS with Fargate is the serverless container option on AWS. You define a task definition, and AWS provisions the compute. The ecosystem includes Elastic Container Registry for image storage, RDS for the database, and an application load balancer for traffic. GCP Cloud Run is arguably the simplest of the 3 for this use case. You push a container image and Cloud Run handles serving, scaling to 0 when idle, and scaling up under load. All 3 platforms use the same deployment pattern. Pull from your container registry, configure environment variables pointing to your database, and wire up a load balancer for HTTPS termination. Pick the one your team or employer uses, or the one you want to learn. Once your application is deployed, you need visibility into what it is doing. Observability has 3 pillars: logs, health checks, and metrics. For logging, you want structured JSON output rather than plain text strings. JSON logs are machine searchable and filterable by field. Use a logging library like Winston for Node.js or structlog for Python, and always include a timestamp, log level, request identifier, and user identifier in every log entry. Ship logs to a centralized destination, CloudWatch on AWS, Loki with Grafana on any platform, or a managed service like Datadog or Papertrail. For health checks, expose a /health endpoint on your API that returns a 200 with a JSON body confirming the database connection, cache status, and uptime. Kubernetes, cloud load balancers, and monitoring tools all rely on this endpoint to determine whether your service is alive. For metrics, track request counts, error rates, and latency histograms. These three signals, the RED method, rate, errors, and duration, tell you almost everything you need to know about service health. Here is what a production-ready logging and health check setup looks like in Node.js. The Winston logger is configured with two transports, a console transport for local development and a file transport for production log shipping. Every log entry includes a timestamp in ISO format and the service name. To use it in a request handler, you call logger info with an object containing the request ID, the HTTP method and path, and the response status code and duration. For the health check endpoint, the handler queries the database with a lightweight select one, and if the query succeeds, it returns a 200 with a JSON body containing status healthy, the database connectivity status, and the process uptime. If the database query throws, the handler returns a 503 with status unhealthy. This single endpoint gives your load balancer, your container orchestrator, and your on-call engineer a reliable, machine-readable signal about whether the service is fit to receive traffic. Now it is time to build. The challenge is to deploy your full-stack API, the one you have been building across months 2 through 4, to a real cloud environment with a working CI/CD pipeline and monitoring. The stack is a React frontend, a Node.js Express backend, and a PostgreSQL database. The challenge has 4 parts. Part 1 is containerization. Write the Dockerfiles and the Docker Compose file. Part 2 is the CI/CD pipeline. Create the GitHub Actions workflow. Part 3 is cloud deployment. Stand up the cloud environment and deploy. Part 4 is monitoring. Configure logging, health checks, and a basic dashboard. You have roughly 120 minutes for parts 1 through 4, and the final 30 minutes are for testing and validation. Part 1 gives you 30 minutes to containerize all 3 services. For the front-end Dockerfile, use the 2-stage pattern, a builder stage on Node 18 Alpine that runs npm sci and npm run build, and a serve stage on Nginx Alpine that copies the compiled dist directory. The final image should be around 25 megabytes. For the backend Dockerfile, start from Node 18 Alpine, copy the package files, run npm c with the production flag, copy the source, expose port 3000, and set the start command. For the Docker Compose file, define all 3 services, front-end, backend, and database using the official Postgres 15 Alpine image. Pass the database credentials as environment variables from a .env file, which you must add to your Gitignore. Set up a named volume for database persistence and a bridge network so the services can communicate by hostname. The acceptance test for part 1 is running Docker Compose up with the build flag and verifying that all 3 services start without errors. Part 2 gives you 40 minutes to set up the full GitHub Actions pipeline. Create a deploy.yml file at .github workflows deploy.yml. Configure it to trigger on pushes to main and on pull requests to main. Define the 3 jobs in order. In the test job, use actions setup node at version 4, run npmc, run the test suite with coverage, and run the linter. In the build job, log into the GitHub container registry using the GitHub token secret, no additional credential setup required, then build and push the image tagged with git sh. In the deploy job, use the Appleboy action to connect to your cloud server using an SSH key stored as a GitHub secret. Pull the new image from the registry and run Docker Compose up to apply the update. After pushing to main, watch the Actions tab in your GitHub repository and confirm all 3 jobs go green. A failed test should block the build. A failed build should block the deploy. Part 3 gives you 30 minutes to stand up the cloud environment and deploy. Choose your platform: Azure Container Apps, AWS ECS with Fargate, or GCP Cloud Run. All 3 have free tiers that are sufficient for this challenge. Install the Plurm CLI, as for Azure, Oz for AWS, or Cloud for GCP. Create a project, authenticate, and create the container environment. Pull your image from the GitHub container registry and deploy it to the platform. Configure environment variables, particularly the database connection string, through the platform's secrets management, not in plain text. Wire up HTTPS by provisioning an SSL certificate through the platform's load balancer or managed certificate service. On GCP Cloud Run, this is automatic. On Azure and AWS, it requires a few extra steps. Once deployed, hit the /health endpoint on the live URL and verify you get a 200 response with status healthy. That is your acceptance test for Part 3. The challenge has 5 deliverables worth 100 points. Multi-stage Dockerfiles for both the front-end and back-end, committed to the repository, are worth 20 points. A working Docker Compose YAML that brings all 3 services up with a single command is worth 20 points. The GitHub Actions workflow at .github workflows deploy YAML with test, build, and deploy jobs triggered on merge to main is worth 20 points. A live production URL where the application is accessible over HTTPS is worth 25 points. This is the highest weighted deliverable because it requires everything else to be working. Finally, a monitoring dashboard or screenshot showing logs and health check status is worth 15 points. Passing score is 75 out of 100. The rubric is in Challenge on DMND. Read it before you start, so you know exactly what each deliverable requires. A few practices that will save you significant time today. Always test locally before pushing to CI. Running Docker Compose up with the build flag locally catches Dockerfile errors and environment variable problems in seconds. The same errors caught in a CI pipeline take 3 to 5 minutes per iteration. Use Alpine base images everywhere. Node 18 Alpine instead of Node 18 saves around 850 megabytes per image, which translates directly to faster pulls and faster pipelines. Use structured JSON logging from the start. Plain text logs are much harder to query and filter once your application is in production. Store all secrets in GitHub Actions Secrets or your cloud platform's secret management, never in environment files committed to the repository. And finally, use semantic versioning tags alongside the git SHA tag for your images. The SHA tag gives you traceability, and the semantic version tag gives you a human-readable deployment history. Before month 6, there are 6 offline milestones to work through. The first is Kubernetes. Set up a local cluster using Minikube or Key3s and migrate your Docker Compose application to Kubernetes manifests, deployments, services, and a persistent volume claim. The second is security scanning. Add Trivy or SNCC to your CI pipeline to scan your Docker images for known vulnerabilities on every build. The third is blue-green deployment. Implement a zero downtime deploy strategy where traffic shifts from the old version to the new version only after the new version passes a health check. The fourth is auto-scaling. Configure horizontal pod autoscaling in Kubernetes or equivalent auto-scaling rules in your cloud platform. The fifth is a disaster recovery plan. Document what happens if your database is lost, test a backup restore, and measure your recovery time objective. The sixth is an Azure AWS or GCP certification course. Invest in the fundamentals of whichever platform you chose for this challenge. These milestones are the foundation for month 6, which covers distributed systems and microservices.